Yeah, I forgot to start the recording. So all our sessions, as stated, are recorded. I have a YouTube channel that I will upload all the lectures up to my YouTube channel so you can view them at a later date. So there's two sets of videos. There's the first set that has already been pre-made, which covers all the chapters. Those are pre-made, and those are by Dr. Kim. She is the person in charge of all Chem 130. And so you have two options here to view this topic, one with Dr. Kim using the pre-made videos, and then you got the videos that I will make here. So you have a variety of resources. Now also, if you do a search in YouTube and you type in the topic we're talking about, you're going to get like thousands of videos out there to view. So you have a lot of resources to help you out with respect to the topic matter. So don't hesitate to tap into all these resources. So attendance is defined as not only attending class here, but doing the assignments. You can have assignments to do. We'll talk about that in a second. Homework, and then you have activities. And so being online, doing the activities is part of attendance, not only allowing attending the Zoom sessions. So we have some requirements here that you must, if you do not, quote, participate in at least 7, you go over 7 days of not participating, then I have to either, I'm going to send you an email saying, hey, I've not seen you on Canvas. I'm not seeing you on the Zooms, on Zoom, you're not participating, so I have no option but to withdraw you, and I don't want to do that. So, keep up with the lessons. We shouldn't have any problems, okay? All right, so if for some reason you need to drop the lecture, because remember the lecture and the lab are two separate classes. If you drop the lecture in the first 10 weeks, then you must drop the lab. If you are taking the lab. If you're not signed up for the lab, you must do so because you can't take one without the other. So make sure if you already took the lab in the previous semester, then you're good to go. But if you're not taking the lab and you're taking this lecture, make sure you are signed up for a lab. Okay, so some students want to withdraw the class toward the end, and that's okay. That's okay. We can do that. But if you take the final exam, I don't have the option to withdraw you. So consider that if you're making a decision to withdraw the class. If you take the final exam, I can't withdraw you from this class. Here's a scale, standard scale. 90, 80, 70, 60, etc. You're going to have a variety of activities. Literally every chapter has an activity, variety of things you'll be doing. It's going to be worth 25%. The activities are 25% of the overall grade. The lowest score of one of the activities will be dropped. All the homework, all the chapters have homework. All of it's online, obviously. Okay, that's also worth 25% of your overall grade. And one of the lowest homework will be dropped. Okay. Now, with respect to activities, you have one attempt for all the activities, just one attempt. Homeworks have 2 attempts. So, and Canvas will keep the highest grade. So you have a choice here. You do the first homework, maybe you're not happy with it, do it again, you'll keep the highest. Now, what some students like to do, and I say that works pretty well, is since you have 2 attempts of the homework, some students, without covering the chapter, go and take the first attempt just to give an idea of where they are at with respect to that homework. You may read that chapter, the textbook, and just go ahead and take the exam, the homework part, and then once we cover it, go back and then do the second attempt. So that kind of helps some students out with respect to the homework. So I do note something about due dates. You have 2 attempts and everything has a due date, okay? Homework has a due date, activities have a due date, and the homeworks and the activities will be open, open until the end of the semester, but there's a late penalty. Okay. Now, all exams have a set date. There's going to be 5 exams, and they're going to be with 30% of your overall grade. There's a certain dates. We can't change those dates. If there's a problem with respect to, personal matters, let me know ahead of time. If you can rearrange I can rearrange the exam to take it maybe 2 days before or 2 days after. But I need to know beforehand if we need to set a different time for that exam. Now, the homeworks, as I stated, they have due dates, and they will remain open to the end of the semester. But if you don't take homework 4 and you decide, maybe take it 2 or 3 weeks later after the due date, it's okay. You can go ahead and do that, but keep in mind you have a late penalty, okay, for the activities and the homeworks. So activities, homeworks are open all the way to the end of the semester, but they do have a late penalty fee. Exams are set up at specific times. We can't change those times unless you got a big emergency, and we can make arrangements for 2 days before, 2 days after. All right, so if for some reason you miss an exam and you can't make it up and it doesn't work out, what I can do is this. I can take the, let me back up before I forget. We have 5 exams, okay? And we have a final exam, which is a comprehensive exam covering all the chapters. Now, that comprehensive exam is all multiple choice, and it's worth 20% of your grade, the final exam. The regular exams are 5 exams, variety of types of questions, multiple choice, short answer, variety of different types. If you miss one of the 5 exams and you can't make it up, I can take the final exam score and replace that score to one of the missed 5 exams. Okay, I can do that for one of them. And so you, out of the 5 exams, you miss one, it's not the end of the world. You just don't miss any more. Okay, and we can substitute the final exam score for one of the missed five exams. All right, now what kind of late penalty for these assignments? Basically 5% per day, okay, until you reach the 50% mark. So how's that work? Well, basically, let's say you have a homework, you haven't done it yet. So after the due date, it starts counting, Canvas starts counting, takes out 5% penalty, and it continues for 10 days at 5%. So at the 11th day, at the most that you can get for that assignment that is late is 50% of whatever grade points that exam or that assignment was worth. So let's say a homework is worth 10 points and you wait till day 11. Okay, well, at day 11, and if you got them all correct, the most points you can get would be 5 points, even though you scored everything right. Okay, so it's 5% per day. So keep that in mind when you miss some of the homeworks, okay, and the activities. All right, so that yellow part is about the exam. If you miss anything, so a lot of stuff here, when you take some time to read it. I want to go over the key parts. Here's our tentative schedule. Tentative because I will not make any homework due or activity due until we finish that chapter. So, and that's why it's tentative. I said I set up the days for the homework to be due, but I gotta make sure that we finish that chapter before it's due. So, if let's say we don't finish chapter 1 until Thursday, well, obviously if it's not going to be due on Thursday, it might give you some time to finish it. Okay, so the only days that are pretty much set, etched in stone, are the exam days, which I've written here to give you, so you know ahead of time when the exams are due. Homework, we can I can fluctuate a little bit with respect to due dates, but these exams we do on those particular days. Okay. So here's our schedule. I put in the last column the corresponding lab. I know I'm not teaching lab here, but if you are doing the lab, that chapter course that week corresponds with the labs that you'll be doing that week. We have spring break, March 14th through the 20th. Okay. The first couple of weeks are pretty intense. We get involved quite a bit very quickly. And then what tends to happen after about the second, third week, it tends to settle down a little bit. And we're doing about a chapter a week. Okay. But the first couple of weeks, we're pretty much going through a lot of stuff fairly quickly. All right. And then on May 10th, that is the final exam. May 10th. All right. Any questions so far about anything? Yeah. All right. Let me see. Anything else? With respect to exams, no, they're all online. I won't be monitoring you taking the exam, but we do monitor the log every time you do a quiz or something on Canvas. There's a log of, it knows, kind of tells us when one goes away from that page into another page. So, have a little point being is, if you're taking an exam, don't move away from that website. Stay with the exam. It will trigger a point if you move away to search something. It takes, the exams have been set up, so it takes, if you spend too much time looking stuff up, you're going to run out of time from the exam. So, as any exam, come prepared to take it. You don't go on to other places looking up stuff, because you won't finish your exam in time. You won't have enough time, okay? Because the exams are all time, 75 minutes for the exams. That's the time limit. And if you spend too much time away looking stuff up, you won't have time to finish the exam. Okay. All right. Let me see what else. Any questions? All right. A lot of stuff. So do read the syllabus. Okay. There is a lot of information in there for you. I just went over the key points that I want to talk about. Any questions? No questions? All right. All right, so there are some assignments and activities that are due coming up. A little introduction of yourself, and don't forget about those. Make sure you get those knocked out. All right, so what I'm going to do then is I'm going to jump right in. Yeah. Best way to get into chemistry is to jump right in and start doing it. Okay. There are, let me go over a couple of things here first before I proceed with the chapter. Okay, there's a periodic table that you should really download. You need to use during the exams. This is the periodic table that it's on Canvas for you to download. We're going to use this quite a lot, this periodic table. Now, a lot of students see this and they say, do I got to memorize all the elements? No, 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 we're not going to do that. And not at all. There's a lot of information. It looks like Greek here right now, but you're going to notice that this periodic table at the end of the semester is just loaded with information. I'm going to refer to it quite a bit. We also have some tables in there. So you might, download this, get it ready, because you're going to use it quite often. We also had the shapes table, which you're going to use quite a bit. Okay, so those are the two things. Now, if we look at that periodic table, underneath that symbol, notice there's a couple of letters there. Those represent the symbol of the elements. Underneath there is a number, and it's called the atomic weight. We'll get more detail about that. And we're going to need those numbers at a future date with respect to figuring out the atomic weights of compounds that we're going to be talking about. Now, you can very readily go to Google and say, hey, give me an atomic weight of, look up the atomic weight of carbon, and you're going to come up with all kinds of numbers. Our recommendation is this: use the periodic table that we at Chem 130 supply. And why is that? Because Canvas is not so smart with respect to numbers. All the answers, whenever we need to use atomic numbers, the answers on Canvas are based on the atomic numbers of this periodic table. So if you use numbers from a different periodic table and then do your calculations, you're going to probably be in error, okay? So use our periodic table with respect to calculations, right? So, which brings me to your point. If you do a calculation in Canvas for assignment or an exam or what have you, and you get it counted wrong, by all means, send me an email and say, hey, here's I calculated, I think I'm correct. We might be off, like 0.01 versus 0.02, for example. Well, I'm not going to count off for that. That's crazy. I will give you credit. So if you think you are correct and Canvas marks you incorrect, send me an email. I will definitely give you credit for it if it's, within reason number-wise, okay? That's because Canvas, like I stated, if you add a space to your answer, Canvas goes crazy and counts it wrong, which is ridiculous, right? You shouldn't be counted wrong for adding a space to your answer. So things like that do send me an email, and I will definitely give you credit. All right. So, okay, well, tell you what, let's jump in it. We're going to talk about, I also teach at SEC, so you're going to see a lot of these GCC and SEC. I teach the 130. All right, so we're going to talk about matter. Chapter 1 is matter. What is matter? Well, basically this. What is chemistry is the question, I guess. By definition, chemistry is the study of the composition, the structure, how atoms are put together, how compounds, how they interact with each other, the properties, whether it's a solid, liquid, gas, okay, and what kind of chemical reactions or processes matter undergoes, whether it's a physical process or a chemical process, okay? Now, all matter is made up of what we call atoms, okay? All right, all of them. So what we're going to learn, what are we going to talk about? Well, the chapters, we're going to talk obviously about the atoms. And now atoms are made up of even smaller components. Now, we call those subatomic particles. We're going to talk about protons, okay? Because atoms are made up of protons, neutrons, and electrons, okay? Now, the protons and the neutrons and the electrons, they themselves have mass. They do have mass. And when the combination of how many protons you have, how many neutrons you have, they all add up and give you what we call atomic mass. Now, here's the thing that's fascinating, at least from my perspective. The protons define what an element is. Okay, there's 118 elements. And from element number 1, there's 1 proton for element number 1, which is hydrogen. And then for element 118, there's 118 protons in the last element. And that is totally, what that does is that the proton defines whether I'm dealing with hydrogen or carbon or whatever element it is. The proton defines that. Neutrons are another particle that elements have, but they don't define. You can lose protons and electrons all day long, or you can gain them, but it doesn't change the property. I shouldn't say, it doesn't change what that element is. The proton defines what that element is. Okay, what that being carbon, which has 12 protons. And here's the thing. Let me, where'd he go? If you go back to the periodic table, you'll see, let's take the symbol of lithium, sit right there. This is lithium, Li, okay? There's a number up at top. That's the atomic number, okay? That tells me there's 3 protons, okay? Now that number in the bottom, 6.94, that tells me what we call the atomic weight for lithium. Now notice the neighbor, which is beryllium, Be. We don't have to worry about the naming at this point, but its neighbor, what it did is it picked up 1 more proton. It went from 3 protons for lithium to 4 protons. And by gaining 1 proton, a simple thing of gaining 1 proton, you have a totally different element. You went from lithium to beryllium. It defined, by gaining 1 proton, it defined the element. And let's say I'm at lithium and I happen to lose 2 protons and I'm back to hydrogen. Okay, so by losing 2 protons, I now have hydrogen. Okay, totally different properties and the whole bit. And the only thing is, I think of it as in terms like Legos. You know, if you can, if you've got a bunch of Legos at home, let's say they're all the same color and the same shape and everything, you can make an infinite number of things using these Legos, an infinite number of objects. And the only thing you did was add Legos or take out Legos. Okay, and it just mind boggles me. Now, the other thing too is that number, the atomic number, like for lithium, I got 3 protons, but what it also tells me, I have 3 electrons. Okay, beryllium, 4 protons, 4 electrons. Hydrogen, we learn in a bit, it has 1 proton, 1 electron. And one of the awesome things about these subatomic particles is when we look at we're going to talk about the relative size of the proton and the electrons. The electrons are extremely tiny, and yet they are so powerful. They're powerful in that they have a big effect on the properties of the element. And right now we're just in the elements because, this is the alphabet of the matter. A, B, C, D, E, F. As we do with the alphabet, we start putting the letters together in the alphabet to create words, right? And then from the words, we start putting words together to create paragraphs, right? Sentences, I should say. And then we put sentences together to create paragraphs and so on and so forth. So chemistry is very, very similar with respect to the atoms because we start putting these elements together to start making compounds. And these compounds can be very small or they could be very humongous. All right, so a lot more on that. Okay, something's different here. Change my Zoom has changed. It updated and it looks kind of different. Okay, so we're going to learn about atoms, protons, and neutrons. From that, we're going to talk about chemical bonding, okay, and reactions. Now, of all the compounds that are out there in nature, when we talk about chemical bonding, there's only two types of chemical bonding, only two types, okay? We're going to talk about reactions, the different types of reactions that chemistry undergoes. And you would think with all the elements that we have, there'd be a whole slew of different chemical reactions. And it turns out there's only about 6 different types of chemical reactions, okay? You drove your vehicle today to go to point A to point B. You had a chemical reaction occurring in your vehicle. You were doing a combustion reaction. Okay. Right now, if you're running out the battery of your battery right now to view this Zoom, there's a chemical reaction in the batteries. Okay. Very specific type of chemical reaction. Anyway, we're going to talk about the different types of chemical reactions. We're going to look at the periodic table. And just by looking at the element relative to its position in your periodic table, we're going to be able to determine the relative size of elements, okay? I mean, even now, your intuition, if we look at that periodic table, okay, you can see here that as we go down the periodic table here, okay, these have numbers 1, 2, 3, 4, 5, 6, and 7. These are energy levels across the periodic table. And as we go down the periodic table, those elements get bigger, okay? We're adding more protons as we go down the periodic table. So it stands to reason that if we look at this element here relative to, say, lithium, you can say that 87 is much bigger than lithium number 3 here, okay? Simply because it's further down the periodic table, okay? So we're going to look at trends here of the periodic table, and you don't have to memorize. You know, they have absolute value, each one with respect to diameter, but we don't have to memorize it. We just look at trends on the periodic table. Like I said, like I was going to say, the periodic table is specific trends we can pick up from the periodic table. And we don't have to sit there and memorize specific values. It's more about observing trends. It's more about deductive thinking here than sit there and do absolute memorizing of things. All right, so let me. All right, now we're going to talk about acids, bases, and electrolytes, okay? Now, an acid. Well, in your stomach right now, you have an acid. We're all familiar with that, right? That's why you take Tums. You gotta take an antacid. And if you take Tums, that's what you do. You added a base to your stomach to neutralize the acid in your stomach, okay? And electrolytes. I'm sure you're familiar with these drinks that you can go buy, so you got to drink your electrolytes. Electrolytes are nothing more than these elements that have lost or gained electrons, okay? And so, for example, sodium, Na. Sodium metal is a very hazardous metal. I wouldn't ingest any sodium. It's very dangerous. It would react with the moisture in my mouth and cause an explosion. But once everything's said and done, once sodium has lost what we call an electron, that is what you ingest. That's what you use in your body. Without sodium, electrical charges, and potassium, electrical charges wouldn't work in your, your muscles wouldn't work. The electrical signals from, stumping your toe, sending a signal up to your brain, all of these wouldn't work unless you had electrolytes in your body. And electrolytes are nothing more than these elements that have lost electrons, okay? We're going to talk about what's called a mole. And that mole is an interesting concept because, when I say the word, hold on a second. We're going to talk about the mole, and the mole is nothing more than a big giant number, okay? Big giant number, and we're gonna talk at length about the mole, and then stoichiometry. Stoichiometry has to gets me sometimes about chemistry. They make it more difficult than it really is, and they throw these big old fancy words just to confuse you. But I gotta use the words, okay? And you're familiar with the stoichiometry right now, okay? You got your vehicle, you got your car. Okay, you got 4 tires, your car. Your whole car, there are 4 tires for your car, right? Unless you got a bicycle and you got 2 tires for your bicycle. What the relationship between tires and cars is a 4-to-1 ratio, right? That's stoichiometry. Or if you got a bicycle, 2-to-1 ratio. If you got a tricycle bike, 3 tires to the frame, right? That's stoichiometry. Well, in chemical reactions, we have a stoichiometric relationship that when things react, they got to react with a certain ratio. A lot of times it's a 1-to-1 relationship where A plus B reacts. They react together to form whatever products, but it could be 1-to-2 ratio, 3-to-2 ratio, 1-to-4. It can vary, okay? And that's all stoichiometry is all about, okay? We'll get to it. Now, the intermolecular forces. What exactly are we talking about here? And I'm sure you're familiar with this because I tend to use a lot of examples of everyday things around you. Okay, now, if I had a cup of honey and a cup of water, okay, and we're at room temperature, whatever temperature you're at room, and I do the race, I empty the cups together. Who's going to win the race? Who's going to empty that cup quicker, the honey or the water? What does your intuition tell you? Wouldn't the honey take a little time, right? Because it's thicker, it's more viscous. And so when I flip the cups over, that water is going to go down empty immediately, whereas that honey is going to take a little time to empty from that cup. You might ask, well, why is that? Well, obviously the honey is more viscous, okay? But why is it more viscous? Well, it is more viscous because they're what we call the intermolecular forces of the honey molecules are much stronger than the intermolecular forces of water. In other words, the molecules of the honey attract to each other much greater than the molecules of water. And in doing so, the IMF, intermolecular forces of honey, makes the honey flow slower. Now, how can we make the honey flow a little quicker? Any ideas? What does your intuition tell you? How can it make honey flow quicker?
Heat.
Heat, exactly. And when you heat up the honey, guess what you're doing? You're breaking up those intermolecular forces and allowing the molecules of honey to not interact with each other as strong, and it flows quicker and it flows much more, becomes less viscous. And all these forces, if you would think that with all these different molecules, that there would be a bunch of forces involved. But no, there's only 3 types of forces, okay? 3 types of forces. There's 2 types of bonds, 3 types of forces, 6 types of reactions. Let me see what else. There's not a lot of things going on in chemistry, but even the ones we have, the properties that we end up with are it's just mind-boggling, the things that occur. All right, we're going to talk about solutions, and we're going to briefly talk about some gases, okay? All right, so as any field, there's specialties. And so in chemistry is no different. Just like a regular doctor, you got your pediatrician, you got your family doctor, you got your surgeon, orthopedics, so on. Well, the same way with chemistry. We have a variety of different types of chemists. We have inorganic chemists. My background is organic chemistry. Mine was making compounds, synthesizing compounds. And organic mostly dealt with carbon and hydrogen, nitrogen, oxygen. But there are chemists who deal with inorganic, that are not dealing with anything that's mostly metals. There's biochemists. There's people who deal with physical chemistry, and they're the ones that deal with these type of properties, boiling points, what kind of the physical properties of chemistry. There are some like Dr. Kim, whose degree is in chemical education. Then we got the environmental chemists, analytical, and this is just the tip of the iceberg. So now, I'm not going to say that chemistry is the most important class in your curriculum. No, it's not. I'm just saying this. Chemistry is around you, 110% all around you all the time. Everything that around us involves chemistry. Even as we sit here listening to me, there's chemical reactions occur in your body. Even the simple thing of breathing, and out with the oxygen, out with the carbon dioxide, in with the oxygen, all kinds of things. There's a lot of chemical processes occurring. Batteries, electricity, even TNT or dynamite, chemical reaction. The shampoo you utilize, if you're looking for certain properties, that's a formulation that's been put together for a particular type of shampoo, makeup. It's just all around us, okay? All around us. So let's briefly talk about the scientific method. The scientific method, you probably have used it unknowingly, okay? And we're just going to make you aware of some method of deduction that you've probably already do in your own just everyday process of looking at life. Okay, well, we break it down stepwise. It's step number one, okay? In a scientific method, we make an observation. Something occurred, you make, maybe like this example, it says, all right, I took my soda and I put it in the freezer, and guess what? Boom, it exploded. Okay, in the freezer, the bottle broke. So that's your observation. My soda exploded in the freezer. So you formulate a hypothesis, basically saying, well, why did it do that? Well, maybe ice expanded when it froze. That is your hypothesis. Make a best guess of what you think happened in your observation, okay? So you conclude that, you don't conclude just yet, but you make a guess, you make formulate a hypothesis. Ice expands when it freezes. Then you look up in the research papers and find out, has anybody reported on this? Is there something that has been reported before? All right, so you look up all your science resources. Haven't found much, but you're going to set up some experiments. Okay, so you might want to try, maybe do it again, see if it freezes on you and explodes. You might change the volume that you utilize, you may change the material. So you set up a series of experiments, different conditions, okay, to observe to see if the same thing happens again. Okay, so step number 5 is you analyze your hypothesis and repeat the experiments again if necessary. And you're getting the same results, you draw a conclusion, okay? And once you draw a conclusion, you might publish your works, and other scientists will try to repeat, and hopefully the same thing is going to happen to them. So you come up with a conclusion, and you're basically just using what we call the scientific method, just a series of steps. Make an observation, formulate a hypothesis, research your hypothesis, because there may have been work already done on this, perform experiments, analyze your hypothesis, repeat experiments as needed, and then draw a conclusion. Your conclusion would be, yes, lowering the temperature causes water to expand. Okay, something along those lines. Okay. And then report on your stuff. Observations, very important, especially right now if you're doing the lab. Making sure you be very specific with respect to your observations. They're very important. Knowing the states of matter. Now, the states of matter, there are 4 states of matter, but we're only going to emphasize or talk about 3 of them. And you're familiar with these already. Solid, liquid, and gas. Those are the ones that we're going to focus on, states of matter, okay? And we're going to have more on that here in a little bit. Now, matter is anything that has mass. So all matter, okay, all matter around us is composed of atoms of some element. Okay? Now, how do we depict these states of matter? There's 3 states of matter we talk about: solid, liquid, and gas. Now, the 4th one, FYI, is plasma. Those are basically nothing more than charged particles. We're not going to talk about those. These are the ones we're going to talk about. Now, notice something here. In depicting the different states, we have these diagrams to show. Notice the solid here. Notice how the solid are shown. They're all compacted, very uniform with respect to how they are relative to each other, very rigid, okay? And this depicts a solid. When we want to demonstrate a liquid, then our diagram is such, yes, we still got the spheres here that represent whatever atom, whatever material it is, but now they're kind of a lot more loose. They're not as organized as the solids were, okay? So this would show you graphically a liquid, okay? And then gases, well, look at the space between molecules far apart. They're all separated far apart from each other. So this would depict gas, okay? Excuse me. All right, so some of the properties of solids, okay? Solids have a fixed shape and a fixed volume, okay? And they do, when they are sitting in the solid material, they are vibrating. All atoms are constantly moving in whichever physical state they're in. They are really moving. Now, if in a solid state, they're vibrating relative to each other, okay? There's only one point in time, and we'll get to that, where matter just stops moving. And that's absolute zero. We haven't reached that state yet. We've gotten close to it, but we haven't gone exactly absolute zero. Okay, so generally solids are very crystalline in shape, okay? We can't compress them any further. Why? If you look at the previous picture, they're relative to each other. There's no space between them anymore. If you try to compress them, they are not going to compress anymore because they're already maxed out. Okay. Notice here, we can't push these atoms any closer together than they are. And the same is true for liquids. They're pretty close to each other. Whereas gases, no. Gases are compressible. Okay. There's a lot of space between them, so we can force them together very easily, but not so much as solid and liquids. Okay. And solids have what we have what's called a density. Let me introduce this property here. I wrote the equation here on the right side. This is called density, okay? Density is nothing more than a ratio. We're going to use a lot of ratios here that we're going to use quite a bit. That's going to help us to calculate, do calculations. You know, there's a lot of ratios out there. Your speed, miles per hour, that's a ratio, miles per hour. The money if you work on an hourly basis, $50 per hour, that's a ratio, okay? Density, it's a ratio of mass divided by the volume, okay? Mass over volume. Even the atomic weights of the elements, they have units. It's a ratio. And that ratio business, I want you to remember, because we're gonna use these ratios. We're gonna either use them as written, or we're gonna invert that ratio so we can do calculations. Sometimes these calculations, which we're going to be doing, people are concerned. The first question I always hear is, I can't do the math. Okay, I'm here to tell you. You can add, subtract, multiply, divide. You can do this general chemistry here, okay? We're going to do a little bit of algebra, very little, nothing complicated. Add, subtract, multiply, and divide, and keeping track of your units. Okay, to help out, to do the calculations. All right, so one of the properties of solids is their density. Most solids have slightly higher density than, say, the liquid state, and especially the gas, okay? It's a ratio of mass over volume. Excuse me. Now, ice is kind of interesting about ice, okay? Ice is nothing, ice is simply H2O, water, okay? Now, water is a liquid, has a specific density. Normally, its density is 1 gram per milliliter. But when we freeze ice, what happens, water expands when it freezes, and it changes that ratio, okay? Let me show you mathematically. Let's take a look at okay, we're talking about water, H2O, okay? Now, normally in the liquid stage, water has a density of 1 gram per 1 milliliter, okay? 1 milliliter, that's the volume in metric units, okay? Now, what happens is this. What this tells you is that 1 gram of water has a volume of 1 milliliter. So it's 1 gram over 1 milliliter, okay? 1 gram of water, the mass in metric units. We've measured the volume, we'll have 1 milliliter volume, okay? And at room temperature, say 25 degrees. Now, if we take that same gram of water at 25 degrees and we freeze it 0 degrees, okay, I still have 1 gram, but that 1 gram of water expands. And if we measure the new volume of that 1 gram, it has about now a little bit over 1 milliliter. Okay, ml. Okay. Now, if I take 1 and divide that by 1.1, what is my ratio? It is approximately 0.9 grams per milliliter. The density got smaller, less than 1. And that is why ice floats. Because relative to water, which is 1 gram per milliliter, ice now has a new density of less than 1. Our reference point for density is water. Anything greater than 1 gram per milliliter is more dense than water, and it sinks, drops like a rock. Anything less floats. And that's why ice floats because its new density is now less than 1, okay? You've done nothing to it chemically. All you've done is froze it. And by freezing it, you've changed the density to be less than 1. And that's why it is, why your ice cubes float. Okay. All right, so now solids do not mix very well. They don't kind of intermingle with each other because they're locked in position. They're locked up. Okay. Now, the properties of liquids. Liquids take the shape of their container, but they have a constant volume. Okay. Think about it. I got a gallon of milk. Okay. And if I take that gallon of milk and I put it into a big old pot, the full gallon, I still got a gallon, right? But now the shape of that liquid takes the shape of the big container compared to where it was in the gallon container, right? But I still got a gallon. Its shape is different, okay? So because that's the property of liquids, okay? Different liquids flow at different rates related to this, what I talked about earlier in the beginning, talking about intermolecular forces. Those are the forces of the molecules interacting with each other. The stronger they are, the more viscous they may have. Okay, where I use the example of honey versus water. Okay, and that's all related to the molecules of whatever we're looking at. This will come a little bit clearer when we get more into the IMF. And it's all related to the electrons that we're dealing with. These electrons have a powerful force on the properties of molecules. Liquids, again, are not compressible. Okay, they may compress a little bit, but not very much because, again, the molecules are pretty close to each other. Okay, they're not as rigid as solids, but you can't compress them. They're already close enough, which is a good thing because if this property wasn't true, we wouldn't have hydraulics. You wouldn't have power steering, power brakes, okay, because you won't be able to use hydraulics to lift heavy objects, you know. And again, liquids have higher densities than gases. Okay. Can they mix? Well, if the liquids are soluble, they will mix uniformly, unless they're insoluble. Okay. Insoluble will be water and oil. We know oil and water do not mix. Again, related to the properties, the physical properties of the oil and the water. Okay. Now, gases at this point in time have no shape, okay? They take the shape of the container like liquids, okay? And they easily can compress and expand, okay? And as volume increases as the atoms get further apart, and that volume decreases as the atoms get closer together, okay? They don't have a set volume under these conditions right now. We're going to learn down the road that under certain conditions, yes, they do have a set volume, but by and large right now, no set volume, okay? And they are compressible, and their ratio, their densities are very low densities, okay? Gases tend to mix with each other very readily, like the air around us, roughly 78% nitrogen, 21% oxygen, carbon dioxide, and a slew of different other gases out here. They exert pressure because the molecules are hitting the containers. You know, when you go put air in your tires, right? You got your tires are low, you're below 32 PSI. Well, let's say you're running low, you're at 25 PSI. What do? You go to Quick Trip, fill it up with air, you're putting more gas molecules into your tire, the pressure goes up. You're putting more matter into the tire. More matter in the tire, more pounding, these molecules are pounding up against the inside of the tire, pressure goes up, okay? So Here's a real simple yes or no, where it says solids. Solids have a fixed shape, okay? Liquids, and they have a fixed volume for solids. Okay? Liquids do not have a fixed shape. It all depends on the container that they have, but they do have a fixed volume. Okay? Liquids. Whereas gases do not have a fixed shape and they do not have a fixed volume. Okay, they take the shape of their container. Okay, now with respect to what we call physical and chemical properties. Now here's the thing about physical. In physical properties, we do not do anything to change the structure of the chemical we're working with. Let me give you an example. Water, okay? You got water at room temperature. It's a liquid. It's still H2O, okay? You take that same water, you stick it in the freezer. What do you have now? Ice, okay? You change its physical property from a liquid to a solid, but you still have H2O. You didn't do anything chemically to it. Now, if I take that water and I heat it up and I boil it away, I still have H2O. I've done nothing to change the physical property, the chemical property of water. H2O is still H2O, whether it is solid, liquid, or gas, okay? Nothing is done to the structure of the molecule when we look at the physical property. Compare that to the chemical property. If I take water and I hit it with some electricity, I break water down back to hydrogen and oxygen. And now I change the chemical property. I no longer have water, H2O. I have hydrogen and oxygen, okay? So there's the difference between the physical and the chemical properties. The physical properties, nothing is done to the chemical structure of the molecule. Whereas chemical properties, yes, you have done something to change the structure of the molecule. Gasoline, for example, you take a hydrocarbon, the gasoline, you burn it, you completely change it chemically as a chemical property, okay? All right, so some of the physical properties involved. One, well, first of all, color of the material, the odor. You know, some chemicals smell very nice. You know, like winter green. That's a chemical. These are very nice smelling chemicals. Okay. Then you got stuff that you put in. You have natural. If you have at home, you're using gas at home. They introduce a little bit of a compound called a sulfur-based compound that makes it smell bad. And the purpose of that is because regular propane, regular gas is odorless. So they put another chemical in there that smells bad, so you can recognize any leaks that may be occurring at home. Okay. Taste is a physical, and texture, melting point. Right, that melting point is that temperature that a solid melts. Butter, for example. You know, there's a certain temperature you put in the heat to cook something. It's a solid stick of butter, and then you put it on the pan, heat it up, it starts to melt. At that temperature, that's called the melting point, okay? Its physical state, is it solid, liquid, or gas, okay? We're gonna learn, for example, the physical properties of these elements. Out of 118 elements, only 2 of them are liquids at room temperature here. And it's a physical property. Its density is a measure of its, is a physical property. Solubility, meaning is it soluble in water or is it soluble in oil? Okay. And depending on the type of compound, it's going to be soluble one or the other. Okay. But that is a physical property. Conductivity. Does it conduct electricity? or not conduct electricity. That is a physical property. And whether something is hard, the hardness, like steel could be pretty hard compared to pure iron could be very soft. Okay, so those are physical properties compared to a chemical property. Remember, with respect to chemical properties, we completely change the chemical composition of the material. Okay, explosive, when something blows up like TNT, it's no longer TNT, it's something else, but it's explosive by igniting it, and that is a chemical property of it. Something that's corrosive, or if it's toxic, meaning poison, you know, or doesn't do anything. Inert means it just sits there, does nothing. Or it's very reactive. The moment it maybe reacts with water very rapidly, or undergoes oxidation to make rust, or it just decomposes. Okay, those are chemical properties. Again, the difference between physical properties and chemical properties is the chemical structure is completely changed when it undergoes a chemical change. When it undergoes a physical change, we have done nothing to the chemical properties, the structure. Okay. All right. Tell you what. Let's stop it here. And chapter 1. Let's stop it here, and we'll continue on Thursday. Okay. In the meantime, I didn't get a chance to go over. I'll do this on Thursday. I wanted to go over the Canvas where everything's at. So you haven't, have you not logged in and check it out, go in there, be familiar with it so you know where all your material that you need. Okay, and I'll go over it briefly and then continue with chapter 1. Okay, any questions?
Yeah, I have a question.
Sure, go ahead.
You said at the beginning of the class about like the lab and that we have to be signed up for it. So how do we sign up for the lab?
Oh, well, you just like enroll and find a lab that's open and just enroll like a regular class.
Oh, okay, and does it have to be the same like this class, like chem?
No, it's totally separate. In fact, I'm not even teaching any labs this semester, so you're gonna have a different professor.
Okay, but to do this class, I have to be in a lab, correct?
Yes, that is correct. Yes, so do sign up with one as soon as you can.
Thank you.
Okay. The question was, Rashid, you had, how do we show attendance? Well, I look at on the attendance, not only is this coming here to the Zoom, but doing your assignments. It's the whole thing. So as long as you're doing your assignments and you're showing up on Canvas and doing something, you're okay. Does that answer your question? Can you explain again? Yeah, attendance again consists of doing your assignments, being going on Canvas and doing assignments. And as a rule of thumb, if you're in there twice a week and you're doing assignments and you're turning things in, you're okay. But eventually, like a third, fourth week in there, and if I see that nothing's been turned in, then I'll send you a message saying, hey, you have not turned anything in. You need to catch up on it. Okay. I don't take row, if that's the question, at least here. So after a while, I recognize who's here. I've done this a number of times. As soon as I get to know your names real well, I know who's here and who isn't. Okay. Clear as mud, right? No. Anyone else have any questions?
Yeah.
Yeah, go ahead.
So okay, I wanted to find out, do we move ahead like in covers for the assignment quizzes? Do you like go ahead?
Oh, by all means, you're not, I'm not holding you back. You jump, all assignments are open. If you want to move ahead, you go right ahead.
Okay.
You're not required to wait until we cover it. Yeah.
Okay.
So, yeah, you go right ahead. Now, like I said earlier, what some people do, because of the homework, you have 2 attempts. Some students will, like right now, go ahead and do the homework assignment, see how well they did. And then they wait until after we're done with that chapter, and then they do the second attempt. Okay. So you go right ahead and jump ahead. And some people know they wait until we're done with the chapter and then do both attempts, whichever works best for you. Okay. Everybody has their own means of getting through this online class. Okay. Any other questions? All right, then. Well, then we'll see you guys on Thursday. Okay. And have a good, safe. Be careful out there. I got the corona, so it's a killer, man. Hey, be careful.
One more question. Oh,
yeah,
sorry.
go ahead. Go right ahead.
I was checking right now to see about the lab if they're open, and right now it says all the labs are closed.
Okay, find one that that will work for your schedule, and then find the professor and send them an email. Send them an email.
Okay. And
Okay.
tell them that I'm enrolled in this class currently.
Yes, tell me you're enrolled here and you need to take a class. Now, eventually, if you're still having trouble, let me know and I'll direct you to the departmental chair and explain the situation and then see what they can do. But first, try email the instructor.
Okay, thank you so much.
All right, no problem. Let me know if you're having trouble with it and I'll see what I can do from my end.
Okay, thank you. I will.
Okay. All right, guys. All right, then we'll see you all on Thursday. Be safe out there. Bye-bye.